Okay, let's look at the next part of this question. So the next part, they said in E, when A is a positive integer, will the perimeter of the rectangle always be positive? Explain your answer. So if you look at A, if you're looking at this, so we've just got to explain. We don't have to do any working out here. A squared, well, any number squared, so any number, doesn't matter what the number is. So a square is always going to be positive. Always, it doesn't matter what it is. And let me prove that to you quickly. So if I take the answer, let's just say -3. If I take -3 and I square it, right? That basically means -3 times -3. And we know that a negative times a negative is positive, so it'll be +9. So even if I square a negative number, it doesn't matter. The answer will be positive. So A squared, and especially the fact they've said if A is a positive integer, so now you actually have a positive number being squared over 2 will be positive. So what you basically have, if I just try to illustrate, you've got a positive number being squared over 2 plus, which is adding onto that positive number, 3 times a positive number. So you're going to have a positive answer, whatever that answer is, because it's a positive number squared divided by 2, so it'll be positive. So you're going to have a positive number plus, and 3 times a positive number is going to be positive. And so the answer will be positive. So of course it's going to be positive. So logically, yes, if A is a positive integer, you're always going to get a positive answer. So how would you explain that? You're obviously going to say, when A is a positive, will the answer always be positive? So you're going to answer it, you're going to say, I keep losing my pen, man. The little dot is so tiny. You're going to say a square is always positive. Always, not always. Is always positive and adding a positive will keep it positive. I guess that's good enough. I don't know. It's up to you because it's your wording, so there's no right or wrong way. We'll keep it positive. But that's one way you could have said it. So that's one way to answer that question. I'm not sure what wording you would have preferred to use, because in these type of questions you use your own wording anyway. Then little number F, or little letter F. So F, they've said to you, work out the perimeter when A is -1, A is -2, and A is -3. So we're going to look at those three one after the other. So we've got A is -1, so we've got -1 squared over 2 plus 3 times -1. We've got -2 squared over 2 plus 3 times, let's put the 3 out there, -2. And then they've said we've got -3 squared over 2 plus 3 times -3. And we're going to have a look and see what difference it makes. Well, -1 squared is 1, so that's just 1 over 2. -3 times -1 is -3, so that's -3. So I've got a half -3, which equals -2.5. So that's F. Then for this one here, we've got -2 squared, which is +4 over 2. So I get 4 over 2 minus 3 times 2 is 6. So that's -6. And again, it's minus because it's a positive times a negative. 4 over 2 is just 2, and 2 minus 6 is just -4. And then looking at the last example they've asked us to test, -3 squared is 9 over 2, -3 times 3 is 9. 9 over 2 is 4.5, and 4.5 minus 9 equals -4.5. So that's F done. And it's just basically just substituting the numbers they gave us to substitute into the original expression. And then G, they've said, are your answers to part F valid measurements for the perimeter? Explain your answer. And you'd have to answer for this one, you'd have to answer G, a big old no, they are not valid. Why are they not valid? Explain your answer. And the answer is you cannot have a negative length on a rectangle. They gave you a rectangle. Actually, it turned out to be a square, but you're just going to say rectangle because it doesn't matter. But you cannot have a negative length, and all of those have said to you that the side is negative. So for the first one, the side was negative 2.5, then we got a negative 4, then we got a negative 4.5. Length is a scalar quantity, and scalar quantities cannot be negative. Only vector quantities can be negative. And then it says, are there any negative values of A for which the perimeter is a valid one? Well, we've gone from 1 up to 3, and going from 1 to 3, every time the answer got more negative. It went from minus 2.5 to minus 4 to minus 4.5. So making A bigger is just going to make that side more negative. So what I've got to do is I've got to look and see, what if I made it smaller? What if I made A, let's say make A a half? Let's see what happens. So if I say, well, in fact, I think the easier way to do this, let me do this. Let me go and see what A would have to be. If I can find this stupid pen again, there we go. So if I said, we've got the expression of, our expression was, what was it again? It was A squared over 2. So it's A squared over 2 plus 3A. Let's make that equal 0, because then if it's, or even let's just see, let's make it equal to 1. So let's just see if we can get an answer that might be negative that would give it. I'm just going to test this first. So if that was equal to 1, I'm going to multiply everything by 2 to get rid of that 2. So I'm going to get A squared plus 6A equals 2. Have we done quadratic equations? I might be doing something that we haven't done yet. A squared plus, oh no, this is not going to work. This is going to give me a nasty equation. So let me just get rid of this because this is not going to work. I'm just going to substitute a fraction. Let's do it that way, because otherwise we're going to have to do completing the square and all sorts of weird stuff that you wouldn't have done in year 9 yet. So I'm going to be working with, if I can find the stupid pen again, there it is. So it's A squared plus 3A. Let's just say A equals a half. Let's do it this way. So we've got a half squared over 2. Oh, but you want a negative a half, I want a negative a half, negative a half squared over 2 plus 3 times negative a half. Let's just see where we get with that. Now, a half squared is a quarter divided by 2 minus 3 over 2, or 1.5. Let's just make it 1.5. Well, a quarter is an eighth minus 1.5. Now, I don't need to do the maths. I know that 1/8 minus 1.5 is going to be negative because that's bigger. Let's see if we change that from a half to a quarter. What if it was minus a quarter? What if we used that instead? And we say that A is going to be, I should be able to, no, don't do that. Why is it not working? That's annoying, having to delete it one at a time. All right, so let's just say A is minus a quarter. Let's go even smaller than that and just see. And this should be all we need to do. So if A is minus a quarter, what are we going to get? We're going to get minus a quarter squared over 2 plus 3 times minus a quarter. Okay, and I've thrown away my minus over there. So minus a quarter squared is 1/16 over 2 minus 3 times a quarter is 3/4. Well, half of a 16th is 1 over 32. So we're going to get 1 over 32. And can you see what's happening? I don't know if you can see what's going on here. But every single time, oopsie, I'm going to get, it doesn't matter how small I make the fraction, I'm always going to get a smaller and smaller and smaller fraction on the left, subtracting, even though the fraction is getting smaller, it's always going to be bigger. The fraction on the right is always going to be bigger than the fraction on the left. So the answer is always going to be negative. So what I've done here by using fractions, I've shown that even if I change the value of a down to its fractions and make it smaller and smaller and smaller, it doesn't change the fact that I'm always going to get a negative answer. So to answer their question then, are there any valid measurements where a is negative? The answer is no. So I'm just going to put a great big old no over there. I've proven it by calculating by getting smaller and smaller and smaller fractions. Doesn't matter what the value of a is. If it's negative, I get a negative length, and I can't have negative lengths of a rectangle. Okay, I hope that makes it a little bit clearer. I know this one was a little bit confusing, but I'm very proud of you for tackling the difficult ones.